a really important mountain skill that translates really well to winter travel and avalanche hazard mitigation is map reading. So there's a few pieces of important information around the edge of the topo map which is worth knowing about. The first piece is the name of the map. In this case it's Rendezvous Peak. And I have a view of exactly where in the state of Wyoming it is. I also have information on what maps surround this map. So if I'm traveling a long distance, I can figure out what other topo maps I need. Another really important piece is the scale of the map. In this case, it's 1 to 24,000, meaning 1 inch on this map is 24,000 inches in real life. The other piece of the puzzle that I want to know about is the contour interval. In this case, it's 40 feet. And that comes into play in determining slope angles of places I may want to ski. The last piece of the puzzle that's important for me is this little rose here. This tells me where true north is versus magnetic north. The top of a topographic map is always drawn for true north. So in order for me to determine which way this map needs to face, this is going to help me. So one of the first things I do when I am going to use a topographic map is I orient the map. Remember, the top of the map is always drawn to north. So in order for me to figure out what direction this map should be facing, I grab my compass. And the red needle in my compass is always pointing to north. In this case, it's pointing to magnetic north, which is somewhere around Hudson Bay rather than at the North Pole. In order to compensate for the difference between true north, or the North Pole, and magnetic north, I have a diagram on this topographic map that tells me the difference. In this case, the difference between magnetic north and true north is 14 degrees. What that tells me is my compass will be pointing 14 degrees off of true north. So I'm going to orient my map. The way I'm going to do that is I can tell my needle is pointed the exact opposite way my map is. I'm going to turn my map. I'm going to take the center of my compass, that little pivot spot, and I'm going to put it right on this center, this little apex of our diagram here. And I'm going to rotate this until my needle is pointing right along that magnetic north line. Or, in this case, I've got numbers around here, so until my needle's pointing to 14 degrees. At this point, my map is now oriented to the landscape around me. A few pieces to note, there are different colors on this map. Green means a forested area, and white means non-forested. Could be a meadow, could be above tree line. On these maps, we then have all these brown lines, and these lines are called contour lines. And remember, we looked on our scale to see what the contour interval. In this case, there's 40 feet between each one of these brown lines. When I'm looking at topographic maps, the closer together these lines are, the steeper the slope. The further apart, the less steep the slope. So if I'm thinking about places that I want to travel, I can look to see how close together the lines are. Great feature about this crystal card is that on the back of this crystal card, I can actually have a slope index. So I find my scale, 40-foot intervals on a 1 to 24,000 foot map, and I can line this up to match the spacing between the contour lines. I then have an idea of how steep that slope is. This gives me an idea of, am I going to be traveling in avalanche terrain or am I not going to be traveling in avalanche terrain? Really important in terms of planning a route. Because these topographic maps are a two-dimensional representation of a three-dimensional world. In order to help our eyes see that, I gave us a little example on my knuckles. So when I go from a three-dimensional world where I can see the summits and ridges and drainages to a two-dimensional representation, I'm looking for the round circles, which are the high points or the peaks, the summits. I'm looking for V's pointing downhill, which are ridges, and V's pointing uphill, which are drainages. So to translate Knuckle Mountain into a topo map, looking along the Mount Glory ridgeline, there's a high point here at 10,086 feet, another high point here at 10,032 feet, and another high point here, this round circle. If I go down from these circles and my V's are pointing down, that's a ridge. As I travel down from that high point and my V's are pointing up, that's a drainage. The closer these lines are together, the steeper that drainage or that ridge is. That's the foundation of reading topographic maps.